Bacon always replies with some retort like that.
Hold up.
That just obfuscates the point.
All right, hold on. Let me ask Bacon a question. Bacon, if you have a building, a very, very tall building, and let's say you have black and white checker squares, black and white squares, 5,000 rows going all the way up the building, 5,000 rows. Now, if you're far enough away and you're at the right angle, maybe you could see all 5,000, okay? You get closer to the building. You're getting closer and closer. Now you're like 20 feet away. You probably can't even see all of the checkers at the very top at that point, depending on how tall the building is. But then you get 10 feet, 5 feet, 4, 3, 2, 1. Now you're right up at the surface. How many black and white rows of squares will you see of the 5,000?
Gio, you said the same thing.
No
you didn't
idea.
respond to what I said before, which is
But
that
I want to hear what Bacon.
Let Bacon reply.
Yeah, can we let Bacon
Yes,
reply?
no idea.
You have no idea, but okay, of the 5,000, like estimated, like 80, 300, 10. I mean, I know it all depends on like,
That depends on
how
many things.
close down or how close you get to the wall.
Yeah, if we assume like the wall of the building is like perfectly flat, like smooth, perfectly flat. So if I get my eyes very close to the wall, there's nothing in
Yeah.
between my eye and the last checker square, then all of them would be within my sight, but I wouldn't be able to distinguish the ones that are too far because they'll be too small to distinguish between them. But all of them
Right,
should be within
and
my sight. If that's perfectly
And
flat.
yeah, so what would be cut off? Because if you can't see all 5,000, there's a cutting off, right? Even though it's a planar surface.
I don't think there would be a cutoff. I just
But you
wouldn't be
can't
able to
see them
distinguish
all. You
between
can't
them.
see all 5,000. It's impossible.
Yeah, but they're all in my sight, so there's no cutoff. They're just too hard to distinguish between each other
My
because they're
God,
all
stop
too small.
equivocating.
Yeah, but that's
Yeah,
converging
I wouldn't
together
expect a
to the point of
cutoff there.
invisibility is the horizon.
Things don't sit flat on the ground. The whole point is that if there was something at the end of the building, you would still be able to see it. I'm not
Well,
talking
then you
about
would be
looking
able
at
to
the
see all
surface.
5,000 squares, which you can't.
Yeah, well, I mean, you can. They are in your vision. You might not be able to distinguish them individually because they've become
Right there,
so
see?
narrow.
See?
Like I said,
Now
this
they
is a
have
false
to
equivalence.
obfuscate between not see and see. Well, no, you see them, you just don't resolve them. You
Well,
don't
like I said before,
see them.
Well, that's
like
why
I said before,
he's
this is
mentioning
not the issue. This is not the issue. It's if we hung something over the side of the building that was hanging right at the top of it, no matter how tall that building is, as long as it was perfectly flat, you would always be able to perfectly see that object if you could, if depending if your eye was powerful enough or what kind of camera.
No, that's
you're
not
using or whatever
correct.
you
No,
want
That's
to do.
incorrect.
let's go back because
That's
it is
incorrect.
the issue. Like what Geo just walked through is the issue. Your tacit presumption that if the surface is horizontal, then there won't be any obfuscation, no disappearance. It would all be visible. Wrong. That's why he went through the walkthrough. The walkthrough
Talking
clearly
about-
demonstrates that you can have disappearance at a given distance, including bottom-up
Talking about-
disappearance at a given distance, whilst the surface is horizontal.
Yo, B3, can you
Talking
see
about
this
bottom
video?
up,
This is gonna save us ton of time. Just can you play the video?
is in live stream one.
Yeah.
But this is a false equivalence. We're not talking about the surface of the building. We're talking about things that stick out of the surface. If we're talking about bottom-up obstruction, like a mountain.
All right,
for
you made a
example.
claim.
No, you're just trying
This
to
video
digress to something
debunks your
else.
claim. Like let's
Go
just
ahead,
to expedite this. You made a
Okay, I'm
claim.
looking at it. Hold on.
Your claim is wrong. So just if you pause the video, I think it's like what 20 seconds or something. 30 seconds long. 30 seconds
I'm
long.
gonna play it on repeat I'll play it on repeat a few times on the live stream right now.
Well,
All
like,
right, so
okay.
okay. Do you see at the beginning of the video that you don't see the mountains?
Hold on, I'm looking. And for the record, oh sorry, I think Witsit, I think you missed the beginning of the conversation. I guess it's not worth going back and talking about, but
Doesn't really matter because I heard you say that unless there's something physically blocking it, then you would always see it, and that's just objectively incorrect. So you just see the video. Like at the beginning of this video, you don't see the mountain. Okay.
Okay.
So according to the globe math, that this mountain should be practically completely obstructed, like 90 something percent of it should be geometrically obstructed. So in your paradigm, you would have to believe that this mountain was refracted up. And, we know the 2 days a year this is going to happen in advance because of the angle of the sunset. And so I guess cool story, bro. If you want to believe that, we just can know the refractive conditions are going to match, whatever, years in advance. But so in your paradigm, in the globe paradigm, that mountain is blocked by Earth curve, but it's lifted up because of refraction. At the beginning of the video, you can't see the mountain. Okay, so why can't we see the mountain at the beginning of the video?
Uh, I would assume I need to look at this video more while I'm not having a conversation as well, but I would assume it's because, I mean, it looks like the atmosphere is incredibly strong here and it's refracting a lot of orange, like ambient red and orange light into the air.
What? It doesn't
Like
change.
a sun,
If
like a
anything,
sunset, for example.
if anything, that variable would get stronger as the sun gets lower. Right. So one thing we know for sure, though, and you've already invoked something additional to physical obstruction of the Earth. So it's like the answer clearly is that the light is absorbed into the atmo. It's called attenuation. So the ambient light, the light that's allowing us to see the mountains, is getting absorbed into the medium of the air between us and the mountain. So we can't see it. It can't make it to us. It's absorbed too much. It's attenuated. Then when the sun starts to get behind the mountain, we can see it again. That's because the light from the sun is way more intense. It's way brighter than the ambient light. So that intensity of light is then able to make it through the air to us without attenuating. So once the sun becomes more of a in line of sight of the observer, more in line of sight of the observer, that's the actual light source we're seeing. We're able to actually make out the mountains. This video, not only is it like not in line with the geometric prediction of the globe, but it proves that even within the globe paradigm, you would have to admit that, even under, around 150 miles, there are times where the air attenuates the light to where we can't see things in the distance. So, like, if a globe earther, according to what you had just said and what most globe earthers seem to believe, if they had gone out there and done the math and been like, okay, I'm at this observer height, there are mountains this far away and they're this tall, and then we looked over there and we couldn't see the mountain, a typical globe earther would tout victory. See, the reason we can't see those mountains is because they're behind the earth, the curve of the earth. And if the earth were flat, we should be able to just see the mountains. They should be right there. They're only 160 miles away. We can't see them because they're behind earth curve. But then if they just waited a few seconds later, they would see, no, that couldn't be what was hiding them, because we see them a few minutes later, right?
Wait,
So
can
the
you
claim that only
cite
the Earth
the?
can physically.
Sorry, do you have a citation just for my records for the data in this video?
Yeah, sure, it's a professional photographer. So yeah, I can grab it in a second.
Yeah, there's just like a link for it.
Okay, so to avoid that, like, I'm cool with you asking for that. You should always verify everything. So, but let's just say that all the data that's in this video is legitimate. Right. Let's just say that it is. Do you agree that this would then prove your initial claim wrong?
Well, I personally don't know all the details about refraction and whatever else could be going on, so I just don't know, to be honest. So that's why I was just asking for the.
But you're now whether it's refraction, whatever it is, you're agreeing that there are, in fact, things that can cause the object to be obstructed in the distance, and it doesn't require physical Earth curvature or some physical object in between us and them blocking it.
Yes, but we were talking about like very pure kind of like theoretical sense if you're looking down a flat plane. And also we were talking about like much shorter distances. We're talking about the length of a building, for example, or the length of your table. This is the part of the conversation that you missed. There was a video posted that was looking up a building we're asking, how do you know that the building is straight? And then we were talking about, oh, if there's a checkerboard on the side of the building, how come you can see less of the checkerboards as you get closer to the building? I was saying that it's not about seeing the face of the side of the building. It's about seeing objects that would protrude from the face of the side of the building. So there's a couple different things that we were talking about. Sorry to throw like 5 things at you, but
But that doesn't
yeah.
really matter though, because the conclusion that you asserted was that something in the distance is going to be visible on a plane unless there's something physically blocking it, like an object in front of it. And that just isn't
At,
true. And that is
at
what the
short
typical globe
distances,
earther thinks, and it's just objectively wrong, right? It's
well,
just
there's a
objectively
few
wrong.
things. Yeah. Sorry, my bad.
No, it's pretty simple. It's
No,
just
yeah.
objectively wrong. So, like, okay, then just to explain this further real fast. So, like, attenuation, right? We covered that. That's the absorption of light into a medium. So it's the same reason that if I have a laser and I shoot it down my street, it's going to go further than if I shoot that laser in the ocean. The laser's not going to be able to go as far in the ocean, right? Because the density of the ocean is much greater than the air on my street. So attenuation is based on density and turbidity. Those are the two prominent variables of attenuation. So the turbulence of the medium and the density of the medium, right, is going to it's going to be proportionate to the rate of attenuation. Okay, so now if we think about this in the real world, where is the air the most dense in the atmo?
Low, low to the ground.
Right. And that's also where there's the most turbulence. So we would actually expect, I mean, it would be required, right, that the light attenuates faster at the bottom of the atmo than as you go higher up. So the rate of attenuation would be inversely proportionate to an increase in altitude. Right.
Right. But what does something
I mean,
look like when it gets attenuated over distance? It fades
Well,
out.
we're sitting here looking at it. Yeah, like you can't see it at all, and then you can see it. So if that, you know, that's the point. The point is like you could look over there at the beginning of this video, and it's identical to what a glober would claim it would look like if it were behind the curve of the Earth. And we all know this. Everyone in this room knows this, right? Like if I had met up with the globe and like, let's go test the globe, we're gonna go here and look at the Canigou Mountains. And if we had gone out there and we went over there and looked, because the globe prediction was that the mountain should be blocked by a curve, and then we saw what we see at the beginning of this video, then the globe will like, see, matches the globe prediction. It's it's obstructed by Earth curvature. Because you can't see it. You can't see the mountain at all. You can't see anything.
My contention
I don't know.
the whole time was that purely increasing increasing your elevation so that you can get a larger angular sorry, I'm forgetting the exact term y'all used, but
Angle of view.
basically, yeah, exactly. So increasing your elevation gives you a larger angle of view, and that's why you can see things off in the distance is verifiably wrong, especially, and you can verify this at short distances, like looking down a hallway, looking down a table, looking up a building, like the video was posted in earlier. You can see all the way to the end of the hallway, the table, the building. If this was
What?
a real phenomenon, I'm not even talking about. I'm saying if you put your
Did no
eye
glober
right
in the
down.
room step up to correct you? Because that's the
No, I think
part.
we've
That's
I'm
the
not
part.
paying attention.
pretty much been in agreement.
That's the
You
part
started
that's
talking about the
annoying. I'm gonna
atmosphere.
start always bringing that up. Glober should step in because, like, the last like week, I've just been constantly correcting flat earthers. I think that people should do this on both sides. This is the worst globe argument that exists. I mean, maybe not the worst, right? There's a few that are really bad, such as like you could see Mount Everest across the world or whatever.
No,
This
no,
one is
you're
bad. That like
misunderstanding
this
me.
idea.
You're,
You're basically
you're
what like you're
misunderstanding me.
saying. Wait, well then let me say what I think your point is, and then
Wait,
tell
sorry.
me if I'm wrong. Okay. So it's like this idea that we see the sunset, and then if I go to the top of the Burj Khalifa, whatever that building's called, the world's tallest building, I can see the sun again, and that's because the Earth's a ball. And then the flat earther would say, no, that's not exclusive to the Earth being a ball. As you increase your height, you increase your angle of view. You can see further, and you're saying that that's wrong.
So first of all, I wasn't making a claim about the shape of the Earth or curvature. I was simply someone else made the claim that you basically the latter part of what you just said, which increasing your elevation will always increase your angle of view, and you can see things further. That is incorrect.
It's not though. So that's what I was asking. Was there no glober in the room that said to correct you? It's fine, but like you said, it's verifiably not true. No, it's verifiably true. Like you could just go
I mean,
to a really really big warehouse and you can lay your face down by the ground, right? And you're only able to see so far and down that warehouse. As you start to stand up, you're going to see more of what's in the distance.
I live in New York City. I have been doing this exact same thing, looking at buildings. I can see all the way to the top. I've done it in long hallways. I mean, so yeah, I've done it. You can see all the way.
I've live streamed this in Discord before. Like I was in a Walmart and did it with my iPhone.
The problem
So,
though
like-
is there's no obstruction though.
Well, that's a
That's
totally different point. Like objectively, as you increase your height above the ground, you're going to see more of what's in the distance if it was completely flat.
When
Yeah,
you
that's why I
do
was
what
saying.
you're, but
That's why I
when,
was saying the checkers. Hold on. That's why I was saying the checkers. Like, if you had a building that was perfectly plumb, perfectly vertical, you have all the checkers, etc., and then because that's what that video shows, and then you kind of take a
Checkers
camera
are
that's
flat.
looking. Hold on. It's a camera that's looking up vertical, and then you take the camera and go closer and closer to the wall. The thing is that let's just say when you were right, like really close to the wall, you could only see, let's say, 40 checkers. But if you lift up an inch, you'll see 50, another inch, 60, 70, 80. And if you keep lifting, if you keep going back, eventually you can see potentially all 5,000 of them. So yeah, I mean, that just shows the higher you go on a planar surface, the more of the surface you're going to see.
Oh,
I just want to say
that's
I
obviously
work in
true.
I work in a factory, and we have done that at my factory. And to start with, floors in factories are not flat; they are wavy as fuck because they're poured in concrete slabs. And number two, you never see a sharp edge cutoff line when you lay down and look. You see a blurry, fuzzy edge. But when you look at the horizon over the ocean, you see a very sharp edge.
No, we don't actually. We
no, we
always
don't.
see a hazy, fuzzy gradient, and I
Okay, I'll
love
post a
when
picture in the
this
chat
art. I okay,
that
please
I
do.
took.
Please do, and we'll just zoom in on it. And this, I love when this argument's made, but unfortunately, what always happens is immediately you just revise your position. So the implications of your claim right now is that on a globe Earth there would be a very hard, distinct cutoff because it's the leading edge of a sphere, right? There's a geometric horizon. Now we're not seeing the actual location of the geometric horizon. Just still man your side, right? We're always in the atmosphere, and so we see the apparent location, but it's a physical location, right? Like there's an actual horizon blocking things in the distance. And so there's this hard cutoff. And this is what you're basically implying. On a flat Earth, you wouldn't get that. It would be like a fuzzy, hazy kind of like gradient that all blends together, right? Now, we do see that, and I then challenge a glober, show me one picture ever where there isn't a gradient. And certainly when you zoom in, because the only time they can even claim that there's like this hard cutoff, this distinct line, is when there's a huge color contrast. So say it's like this picture that if this is you that just posted that, like just zoom in, there's obviously going to be like a wavy, hazy gradient above that water. I don't even have to open the
That
picture.
that that circle around that tree's on an island on the lake. On the other picture, I even circled where I was at, and I even wrote on it where I was at and where the tree's at. Why is the island and half the tree hidden by the
You just
water?
completely deflected, right? Like, so you
That's a
made the
sharp
You just
claim.
edge
discussed
line.
that.
That's a sharp edge line. You said there wasn't, right?
You
There's a
relax.
sharp edge line, and in the same image, there's a half cut off tree too.
No, that's
Relax
not
and
a
just try
What
to
sharp.
is
It's not
that?
answer it.
a sharp, hard cutoff. That's the point. And then once I pointed out that it
It's
wasn't,
not.
you just no. That's my point. So if you
It
open
just
this
makes
picture
my
and
point.
zoom in, which you don't even have to.
Pretty
I mean,
hard edge to
if you
me.
make, it's not. If you
Compare it
zoom
to
in,
compare it to laying down on a factory floor and looking straight down the floor, and they are nothing the same. A factory floor is blurry as fuck when you get down next with your face on the ground looking down it. It is not a sharp cutoff edge like the picture I showed. Ever.
The
okay,
Why is he
point is,
reversing it?
even
if, if you get down with your face on the beach, it's also going to get very blurry, right? Because the loss of information, convergence point is going to be much closer to you. It's always relative to your position above the ground, but this is the point, dude. No image or video exists in the world where when you zoom in on the horizon, it's a very distinct, crisp, hard cutoff. Doesn't exist. I know it doesn't exist because I've made this very observation all around the United States, over all kinds of different bodies of water, and even in infrared. So in
So what?
electro-optical spectrum and in infrared, every time you zoom in, you see a gradient, and it's wavy and hazy every single time. And
Okay,
like
what?
the globe stillman to that would be because it's in the atmo. But to claim that we see a crispy hard cutoff line would
Look,
be you invoking seeing the actual position of the geometric horizon, which your entire belief requires the claim that you never do see that.
Okay. Well, this is my last sentence, real quick, and then I'll hush. Okay, which that's. I just wanted to throw that out there with you a little bit. It's good to hear from you, and I'm glad you made it back from Antarctica safe. And you guys
It was in
continue
Iceland.
Oh my
wherever.
God, I was in
Wherever. I'm
Iceland
glad he
now.
made it back from his
Oh my
trip
God.
safe. Anything could happen. So you guys.
I just
So
like
let's
circle
return to the point that
pretty
we
hard
digress
edges.
from.
well, look,
It doesn't
if,
matter
if
because
for,
you
forget
still
the
have to have an
atmosphere.
explanation for obstruction over a flat surface.
Let's say you're in a hallway. If this phenomenon is real, where as you increase your angle of elevation, you have a greater you can see more things off in the distance. If that's true, it should be really easy to create a mathematical formula saying if I increase my angle of elevation by this much, I can see objects this much farther away, and if they're this tall or whatever.
And
It
if
should
we
be
don't
really
write
easy
that
to
formula,
make.
we don't observe what we observe, right?
And that doesn't even, that's
On,
not how reality works because when we're actually trying to figure out what's going on with the Earth and we go out on the Earth and we make observations, there are all
I'm
kinds
in
of
a
conditions that happen.
I'm in a hallway. I'm talking about a
Just to be
hallway.
clear, B, because this is what usually happens. Because you just said that. So if we don't recite the formula, therefore we don't observe what we observe, right?
I didn't say that.
Okay, so whether we recite the formula or not, that is what we observe. As we increase our height, we have a greater angle of view.
Talking
It
about
should
even
be
in a
very
hallway,
geometrically.
even in a hallway, bro, there's a temperature gradient, there's all kinds of different conditions. So like there's a guy who's replicated all of the things we observe out on the earth in his garage or like this warehouse, right? And what he does is he allows the temperature to settle, different temperature gradients. He'll open up a window, he'll change the temperatures, right? Whatever it is, and he'll show that these same effects happen. Period. So
Okay,
so
fine. So I guess
even
maybe.
in
Sorry, go ahead.
does anyone know the name of that channel that does all the small scale replications? You know what I'm saying? Like the refractive replications in a warehouse.
No, Austin, please tell
Well,
us.
so maybe I
I'm just
just
asking
need a
if any
point
of the
of
flat earthers know the numbers.
clarification then. I guess it's just a point of a clarification. So if there's all these other factors that are factoring into it, is is it true that there is no claim that this would happen in ideal settings and that there's no atmosphere, no anything else, just pure geometry, unrealistic scenario? Is there still a claim that increasing your elevation would increase your angle of view?
No, yeah, I think yeah, of course it would because it's just very basic. You're asking for a specific predict formula that I should be
So
able to
that's all
go
I'm
out
saying
and I mean,
is
you're saying you're asking for a specific formula I should be able to go out and it match perfectly, and even in a hallway or whatever, it's not going to, right? It's based
no,
on
no, no.
aperture. It's based on aperture, angular resolution, due to the
I'm not even talking
aperture,
about
and
prediction. In
whatever
perfect,
mediums are.
in perfect conditions, just a mathematical, pure math, hypothetical scenario in perfect conditions. It should be really easy to come up with a formula saying if you increase your angle of elevation by this much, you can see this much farther. You can't do that.
Again, why are we digressing to that? So if we don't recite the formula that you're requesting, then we don't observe what we observe, like we just went
Did not say
through.
that. Did not say that.
Okay, so then there's no point for you to keep digressing to a recitation of a formula. That's the point.
I mean, I just like the problem with the interruptions. It's not. I mean, yeah, it's obviously annoying and it's not ideal in a conversation, but it's more so it's that you're not listening to the things being said to you, right? Like these are very well thought out, hyper specific points. So like if it sounds like maybe I'm saying a lot, but I'm making like multiple points that are directly relevant. You know what I'm saying? So it's like aperture. Have you looked into Rayleigh's criteria in aperture? Have you seen the test, for example, where the university takes two lasers, changes the aperture, and can make them begin to blend in and merge together. Although the lasers are distinctly different areas, shooting down a hallway, as they change the aperture of the camera, they begin to merge together. Where the bottom of it, like basically, is they merge into each other. So it looks like bottom. It basically looks like a sunset flipped on its side. So that's just
Yeah.
in a very basic level. You have seen that?
I have not seen that in particular, but I understand what you're saying is that there could be a variety of factors which would affect what we're talking about. Yeah, I get that. Which is
Yeah.
why
So
I'm
it's
trying
like,
to separate it to a theoretical. Well, which is why I asked for clarification. Is if in absence of all of those factors, would this still be a phenomenon or not? I'm just a question.
well, I'm explaining to you why it would. Okay, because of just the way that we view things, the way that we see things in perspective, etc. So this is I think it's BYU. Yeah, BYU. This is BYU. They do it, right? But just understanding on a basic level, which is that whatever's below you appears to ramp up, whatever's above you appears to ramp down, and that everything that you're able to resolve is based on aperture. So resolvability is like the number one thing, and your angle relative to the information that's being received is directly relevant to what remains resolvable. And for all intents and purposes, that means being able to see it. It's extremely disingenuous and pedantic to say you can still see it, you just can't resolve it. If you cannot resolve it, you can't see it. You wouldn't even know it was there. Similar to those mountains, you don't
Thank you.
see anything.
No, if there's something protruding out of the ground, you could be able to see it and you could resolve it. Unless it's really, really, really far away. But as long as you had a telescope or whatever, you could bring it back into view on a flat surface.
Okay, like this is what, okay. What like optical device is going to allow me to change attenuation?
Well, this is why this is why I'm trying to clarify is if this is like a purely mathematical thing that you can model, or is it only, or are we only talking about reality where we have all these other factors? And that's fine if we are.
It's so simple. Austin is telling you as to concerns, for instance, the sunset. It is not only because or primarily because it's obstructed behind a convex surface. What he's explaining to you is all these other factors in such an instance where I've pointed to you in the live stream text where I tagged you. These other things are happening so that we see the sunset from a horizontal surface, not because it's obstructed behind a convex surface. So it's accounted for. It's not strongly indicative, nor necessarily indicative of the Earth being a ball.
I'm talking about on a flat Earth. I don't know why you keep bringing it back to. I'm assuming that
I
Earth is a ball.
just
Yeah, but
mentioned
the,
that 10 seconds ago.
it's
You
an
said that
implied
reply to me
exclusivity.
like I didn't just make that point.
It's
But
an implied
also,
exclusivity, right? Like it's always best to say it with your chest, right? Like if what you're saying is what we see, you don't think can work on a flat Earth. That is what you're clearly getting at. Like just say that. That's why I immediately dropped the video to cut to the chase, where it's like many globe proponents are misinformed on
okay,
this specific point.
it doesn't explain obstruction on a flat surface.
Notice
Okay,
how you just
why
said
can't
that,
wait, just
where
wait,
you're just going to presume obstruction.
why can't we see the mountains in that video at the beginning?
So I don't know why, because of haze.
I'm asking you because like you're saying that
I
it can't
think
happen on a flat Earth. So
I think because light from the sun is bouncing off the haze between the observer and the mountains.
okay, and why would that result in us not being able to see it?
The mountains,
Yeah.
is there's something physically in the way, and that's the haze.
Okay. And
Just
so what does that
repeat
do?
the presupposition again.
What does that do to the light?
What it doesn't do is make the mountains set. It doesn't make the mountains
Wait,
go behind something.
where what does it
Right.
do to the light?
It's the light bounces off the particles, right? They bounce off the particles so that you see the atmosphere before you see the mountain. The same way we have a blue sky, because light bounces off the particles.
Okay, and then we're able to see the mountains as the sun continues to set, right?
Yeah, because the sun's light is no longer bouncing off as much atmosphere, allowing you to see the light, or I'm sorry, allowing you to also see the shadow of the mountain. Which also is another
Okay.
point, is the shadow of the mountain has a much higher contrast, make it easier to see than when there was no contrasted silhouette.
Okay. Do you agree that light attenuation is a real thing?
I do, and what I'd like you to do is explain how that makes the moon set.
Okay,
Gotta go,
so
guys. See ya.
this is what always happens. It's just like these random weird deflections, right? So it's like the claim that on a flat Earth things can't be obstructed or obstructed bottom up in the distance unless there's like a physical obstruction of Earth curvature. It's just objectively incorrect. So I show the video that proves that, because if I'm a glober for a second, right, I'm going to be a glober, and then a flat earther shows me that Canigoo video, and they say, look, here's the observer height, it's about 1,000 feet, 160 miles, 161 miles away. The elevation of Canigoo Mountains is like 9,100 feet. So there should be like 90% of this mountain obstructed. Yeah, we can see much more of that clearly. So this is evidence of a flat Earth. And then I would say, as the glober, no, you're not accounting for refraction. And so we know light bends to the more dense medium, and based on the vertical density gradient, the temperature density gradient, or the vertical temperature gradient, that the light's going to bend down, lifting the object up. So those mountains, although actually behind a physical geometric obstruction, they are being refracted and lifted up over it. And it just, that's probably standard refraction would explain this one. Okay, cool. Then if the flat earther said,
This
oh,
is getting way
okay,
far
cool.
away from the point.
Wait, no, it's not. This is the same point. If the
It's
flat earther
not.
then said, oh, okay, why can't we see it at the beginning of the video then? Right? I would say, well, because the light is being attenuated uh, between me and the mountains. But once the sun gets behind it, it's so bright, the intensity of the light is now directly in our line of sight behind the mountains. And so we're able to pick up that information, as opposed to before it was being attenuated. So like in a globe paradigm, you still have to address the fact that you can't see the mountains at first, but then you can once the sun sets behind it. You can't just claim refraction. You can't just claim earth obstruction. Literally, there has to be another explanation as to why those mountains are not observed, even within a globe paradigm. That's the reason that I always bring the video up.
Okay, I'm not sure where the disconnect is. What we're asking is, how does a flat surface block line of sight to half
Okay,
the
he
moon
just
when it's on the
deflected
horizon?
again.
Because the
Just
bottom half
hand
of
wave
the
everything
moon,
Austin just said.
the bottom half of the moon is visibly on the other side of physical Earth, right? Because there's no atmosphere there. There's no attenuation going on, right? The bottom half of the moon isn't being attenuated. The top half is not, right?
Okay,
Yeah, now
first
you're
of
gonna
all,
dig in your heels to deflect again. Just hand wave everything Austin just said to you.
exactly.
He got to the center of the matter.
Oh, it's like a red herring and a straw man of what you're extrapolating from me addressing this point as to what my alleged full explanation of something disappearing bottom up would be. But that's not how any of this works, right? The reason the Globers all deflect away from this is because they love to run around claiming that anytime they see bottom up obstruction, it's exclusive to a globe, can only be explained on a globe, and it can't happen on a flat earth. It's impossible on a flat earth, blah, 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 blah. When so you're provided with direct evidence refuting that, showing that no, even within your paradigm, you would have to acknowledge there's something other than Earth curvature physically obstructing objects in the distance that would cause them to be not visible, right?
So
You just avoid it. You just avoid it. All the Globers avoid it.
we're asking a pretty specific question to describe how attenuation of the bottom half of the moon happens in such
You're
a
just
way
gonna
that the
repeat the
bottom
same
half is
question.
also behind the physical Earth that we see, right? Because we don't see it attenuated, right? Are you asserting the bottom half of the moon is attenuated and the top half is not?
Objectively, in all situations ever, if you're viewing something through the Atmo, the bottom of it would be the light from the bottom of that object, the information that we are perceiving as that object would be more attenuated than the areas higher than it or above it. unless there's some anomalous situation where the density gradient itself is flipping or something, because attenuation is directly proportionate to turbidity and density. The more dense and turbulent portion of the atmo is always at the bottom. I am not claiming that that is the only reason that we see things disappear from the bottom up on a flat Earth, though, because I know that the horizon is an apparent location, so the ground ramps up, the sky ramps down, it creates this convergence point, right, where it's basically a vanishing point. And as an object is higher up and moves further away, it's going to disappear into that location. And so as it's appearing to go down because it's above me, the bottom of it is going to reach that vanishing point first. So like even just in perspective, it's expected. Then you actually add on the variable of attenuation being greater at the bottom. And that's only two of the variables. Like the Globers want to live in this world where everything must have a singular answer and we can exclude all other variables until it comes to us seeing too far. Then we must account for everything, including like, you know, whatever, like who the creator is or whatever. Like, so it just seems disingenuous to me. It would be cool if someone could just address the first part and acknowledge my point. So then, like, as a collective, we could move forward with a higher level conversation than people running around 10 years in claiming that bottom up extraction or things being blocked in the distance can only be explained on a globe Earth. That's just wrong, right?
Well, we're not saying only. We are saying that a flat Earth cannot do it. And right now,
Okay,
Just
so
repeat again. Just went through all that. Just going to repeat the whole thing again.
you said
why?
flat Earth cannot do it.
Nothing
Let
he
me
said
ask the
answered
logical
question.
follow up. You said it can't happen on flat Earth. Flat Earth can't do it. Let's ask the logical follow up. In the Canagoo example, right? What is it that's causing it, and how is whatever's causing it exclusive to something other than a flat Earth?
I didn't say exclusive. I would just like to know how how you can take explain it in any way, not just exclusive.
Let's see if you can answer this.
Something
On a
that's not
flat Earth,
flat Earth.
Austin has a question from Austin.
they never can answer the questions though. But like, so according to your interpretation of a flat Earth, because obviously you're presenting a version of flat Earth here, because you're saying something can't happen on a flat Earth, and we're all sitting here telling you that's a straw man. That's not our position. But Globers rarely seem to care about that. But this is the question here, right? Okay, so should we be able to see across the entire Earth if it were flat?
You're trying real hard, Austin, to change the topic. I don't care
No,
about
See,
that's
the
what
Earth.
you're
dodging the other scrutinizing
projecting.
question from Austin. See,
You're projecting.
The question is, I see the moon rise on my eastern
he's
horizon,
doing it again.
and to my
He's
east is
dodging another
Kansas.
scrutinizing question from Austin.
They're plains, right? When I see only the top half of the moon poking up, what is in the way of the bottom half?
I already answered that
We
question.
can still arguing
No,
perspective,
no.
dude. This is
You
crazy.
started.
I
You
already
started
answered that
listing.
question. I already answered that question, and the fact that you're deflecting over to repeating it without addressing the other points I've made or the video I first brought up, which is directly relevant to the answers, shows that you're just operating in bad faith. And it's just all very simple. You just claimed it. I said we should be able to move together as a collective, regardless of what you think about the Earth, with a higher level conversation where the globe side is no longer making the erroneous and frankly retarded claim that nothing could ever disappear bottom up or disappear or be like not visible in the distance on a flat Earth. That is a ridiculous claim. Okay, you just doubled down on that claim. So I then brought back up the example of Canagoo, where at the beginning of the video you can't see the mountains at all. At the end of the video you can see the silhouette of the mountains. And I'm saying, okay, what
It's
is
not
the
analogous.
reason? What is the reason that we can't see the mountains at the beginning of the video in your paradigm? And whatever that reason is, explain how it's exclusive to something other than a flat Earth. That is the implication of what you just said a second ago.
Is the mountain obstructed in the same way that we see the moon obstructed?
What in the same way?
Is
What
it
do you mean in the
analogous?
same way?
Is it analogous? Do we see? So you posted a video of the sun setting. You asked me about not seeing the mountains and then seeing the mountains. What is obstructing the sun that produces a hard edge, those mountains? And then how is that similar to
Hard
the
edge.
mountains not being obstructed by something, but rather
Okay, so you
fading into view?
okay?
The sun
I've
and the moon
explained
don't
it
fade in
multiple
and out.
times
No, you
that
said the
this
same thing. It doesn't explain it.
you can't address the same thing over and over. So like you obviously are afraid to even just address the actual fact that even as something as close as 150 miles in your own paradigm, variables additional to your belief in Earth curvature cause objects to not be visible in the distance.
I've
And like you just
never.
can't address that.
You're strawmanning me, Elston.
How am I strawmanning you?
I've never said that the only way for things to not be seen in the distance is Earth. Okay, I've never said that. What I'm specifically talking
Okay,
about is
so
obstruction.
oh yeah, but we're not talking about like clouds or another object. We're talking about there are no clouds in between us and the mountain because we see the mountain just a few minutes later. So whatever explains this video is present the entire time. So go ahead.
Yo,
Okay,
Negator.
so
Have you seen like the different pictures of Black Swan and like the horizon changing?
yes.
Okay, so how do you explain that on the globe?
Hang on, you have to wait.
Yeah, it's
Your
very
video you
complicated.
posted, Austin, of a setting sun. As it's setting, there is a hard line of obstruction between the sun and the viewer. What is happening there?
Okay. I just explained that, and I guess this is your open admission. This is like a public forum that you just literally can't address it in good faith. You can't address the point,
I don't.
so
There's
it's
no reason
fine.
to just say
It's
I
fine.
just
No
explained
Glover
it.
can. Basically, it's pretty
All you
pathetic.
have to do is
And
explain it.
if in the worldview that you guys think Flat Earth is wrong, it's your inability to intellectually have intellectual exchanges that has breathed so much life into it. But here I dropped another example of just that very thing: the sun disappearing from the bottom up. The very thing that you're claiming is exclusive to a globe, and it's happening up above the visible horizon. Once again, proving that this false claim of exclusivity is incorrect. It's patently incorrect. So you can't actually even address the other variables because your entire claim of exclusivity relies upon the notion that there are no such variables. And that's why you're actively trying to avoid answering the question and engaging with it in good faith.
Yeah,
Right? I mean, that's
it
obvious
seems
to
you
everyone.
want to talk about me more than you want to talk about the subject. There's no reason to do that. Now, look, what
That
you
was just
posted
that
of
was just a tactic. That was just a
a
tactic.
sun. Yes, you've employed a tactic. I get it.
All right, can some of the flat earthers debate Austin like next? Like the Glovers are like hogging.
No, what has not happened is an explanation for moon set, right? You're using the sun because the sun produces all sorts of atmospheric variables. The moon does not, right? That's why you don't touch the moon.
He's
I know,
already
you know,
explained that
okay?
several
All
times, and you just
sorts
keep repeating the scrutinizing question to him as though he's never addressed
Yes,
it
the
ever at
first
all.
video you
That's your
posted
tactic.
all
does the
sorts
I
same
of
did begin
atmospheric
speaking before he began
variables.
speaking, by the way. I'm not disrupting him.
All sorts of atmospheric variables. Would you like to list them?
No, Austin. What I'd like you to do is explain why the bottom half of the moon is obstructed. Right? You've alluded to there being light attenuation. What you didn't explain is why the bottom half is attenuated, the top half is not, and the bottom half is coincidentally exactly where the Earth horizon is.
First of all, in your paradigm, that's not the actual physical horizon of the Earth that we're seeing, right? That's an apparent location.
Remember, the
I have
question was
addressed it
about
specific.
yours, not mine.
I addressed the moon thing specifically, and I gave two primary things, variables that are at play, right?
Okay.
I addressed it
The
specifically,
first was attenuation.
and then
That's incorrect.
I brought it back to the fact that you're avoiding the actual evidence that's being presented, which now I've presented another piece of evidence, which is the sun disappearing from the bottom up with a hard cutoff, a horizontal cutoff up above the horizon.
Mhm.
Showing once
So
again
one of
that
those.
it isn't just because of Earth curvature. It's just a
You're gonna
fake claim.
monologue. So one of the two reasons you mentioned the moon being obstructed was light attenuation. What I'd like you to do is expound upon that. How does the bottom half of the moon's light attenuate to the observer?
the same way light always attenuates. So the light
Sure.
is going through a medium, it's being absorbed into that medium relative to its density and turbulence. Okay. And they're the most turbulent, most dense part of the atmo that it's being viewed through is the bottom. In fact, there's a gradient. All right. And so it's the greatest rate of attenuation at the surface, and it's lower and lower the higher that you go. That was just one
Would
variable that I pointed out, and I only pointed that one out because Globers all ignore it. Even when I show them the Canigoo video where they have to address it, none of them do. They deploy tactics like you are, where they just try to avoid it.
The problem, though, is that the vast majority of people watch the moon set on Earth's horizon, not high up in the sky where you assert there's some massive amount of attenuation. I watch it rise to my east on the horizon every time. Do
What
you
is
agree
your
with that
obsession with the
attenuation
moon?
or not?
No, dude, the attenuation had to do with whether you could see the mountains or not. Witsit, real quick, would you say that like because the sun and the mountains, like because they're all lined up the way they are in that shot, would you say that it's like the sun like breaks through the like attenuation limit that was previously there and then allows them to be visible?
Yes, yes, because like now, once the sun goes down, because we could see the sun the whole time, like the sun's light is not being attenuated so much that we can't see the sun, like the whole video, right? So we're able to see the sun the whole time. So now that the sun is behind the mountains and we have a direct line of sight to that sunlight, which has a much greater intensity, now we're able to see the silhouette of the mountain, right? So the intensity of the sun is so much greater than the ambient light that we can see it the whole time. The ambient light is not nearly as intense, so it's actually being attenuated in the medium to such an extent that we can't even see things in the distance, even 160 miles away. Now that the sun sets behind it, now our line of sight to those mountains have that intense light behind it, which is visible and has been the whole time, right? So now we can actually see the silhouette of the mountains. And this would have to be the explanation from even within a globe paradigm, right? Which is why the video is so good.
Is the silhouette a hard line?
Never said it was.
That's what I'm asking. Is it?
So it's
Is
like
it
it
a hard
reveal.
line?
It's
What
like
you
it
mean, like a
reveals the
horizontal
line of
line?
sight.
You call it a silhouette, right? Do silhouettes have hard lines?
I mean, it's probably like decently defined, zoomed out, because in reality, every time you zoom in on anything in the distance, it immediately gets very wavy and hazy as you get to attempt to see further detail or see it any closer, which is just a fact. And it's like that with every observation ever. And I'll just repeat my answer again that Negator is pretending I didn't provide, which is that due to perspective, things below us appear to ramp up, things above us appear to ramp down. They then appear to converge into a vanishing point, and we call that area the horizon. And typically, what people do is they point to the greatest color contrast and claim that is the horizon. And then we know, of course, that line, which is horizontal, uh, it's just apparent. It fluctuates. It goes up and down. So when something is much higher above us and moving out in the distance, it's going to appear to ramp down, and eventually it's going to go into that vanishing point, right? That vanishing line that's apparent. And the bottom of whatever it is that's up above us, moving out away from us, is going to hit that vanishing point first. So it's going to disappear into the vanishing point bottom up. An additional point to that is also light attenuates, and attenuation of light is based on turbidity and density. Both of those are the greatest at the bottom of the atmo, at the surface. These are just 2 points that are both objectively relevant. You know what I'm saying? So like that's why the straw man of just attenuation wouldn't explain it by itself. That's never been the flat earth position. This is just the 10-year-old like kind of laughable conversation where Globers just refuse to acknowledge like the stillmaning of our argument in terms of perspective.
How far?
Incoming
Oh,
hand
excuse me.
wave
But how
retweet from
far?
Negator.
Yeah, at what distance from an observer would the moon rise above the horizon of the sea or the sun? Let's say a sunset looking west. How far off must the sun be before it gets to a couple of degrees above the horizon?
It's not an absolute fixed distance, no matter what of the other factors. You're missing the whole point.
Exactly. Like in
No,
any
no, no,
paradigm,
not
we know
really,
that
because
changes.
if
That
it's
changes.
on a flat Earth, if it's on a flat Earth, let's say if the elevation of the sun above the flat surface is about 5,000 miles, he needs to move away from our observer about 142,000 miles or something like that to end up a couple degrees above the horizon.
You're just assuming,
Uh,
for one, that you're seeing the actual position of the sun. But this is what you don't seem to understand, right? Your demand is unreasonable if you actually know what the sun does in reality, because the horizon constantly moves. Like if you time lapse the horizon, it'll go, bruh.
Yeah.
If you time lapse
Well,
the
let's say
horizon,
if I,
bruh,
yeah,
bruh,
okay, but
bruh,
let's say
bruh,
the sun is 10 degrees above that.
bruh. If you time lapse the horizon, it'll move up and down throughout the day and every day, right? So if you're asking me how high does the sun physically need to be over
No,
a flat Earth before it ends up
no.
being 2 degrees, that's exactly what you said. You said how high
Yeah,
does the sun need? That's exactly what you said. How high does the sun need to be? For example, before it's 2 degrees above the horizon. Okay, this is the point I'm trying to make to you, is that if you're measuring degrees above the horizon and the horizon is moving up and down optically, then the timing of where you would get that 2 degrees changes relative to the change in the apparent horizon.
no, it shouldn't affect it that much.
It's just a hand wave. You're just
Dude,
not.
No,
nuh-uh.
yeah, it is. If it's on a flat Earth, if it's just doing simple geometry, if it's 5,000 miles above the surface, when I look west at sunset, the sun has to move about more than 140,000 miles away from me to even start getting close to horizon. How is
What
that
was my
possible?
response to that? What
Do
was my
you see
response to that?
Euclidean mathematical categories, or do you see light?
Wait, time out. You repeated it again. What was
Yeah,
my
it's a good
response to
question.
it?
It's a question.
The,
It was BS. You didn't explain anything.
it was BS.
Just
Okay,
hand
so
wave.
it was,
Yes,
time
you
out.
said, "Oh, we don't know we don't know how we observe the sun." Of course, we do.
I didn't
Everyone
say
does.
that. I didn't say that. I didn't say we don't know how we observe the sun. You made that up. I didn't say that. If what I said is BS, you should obviously know what it is that I said in order for you to then qualify it as BS. So what did I say?
Well, it's sort of sad. We don't actually know if we see the correct position of the sun. It does not matter, does it?
I
Because
said, it,
hang on. When I see it low on the horizon, then it's a sunrise in the eastern part of the U.S. The sun must be in between those places.
totally irrelevant to my point. And you said it doesn't matter, does it? Yeah, of course it matters. Your
Well,
entire the entire mathematical proposition of yours is dependent upon the assumption that we're seeing the actual position of the sun.
and we don't. So if we have three different observers at three different positions and a triangulate, we're still not seeing where the actual position of the sun is.
That's correct. In any paradigm you believe in, we don't see the actual position of the sun. That's correct. You didn't know that. Like to even try to figure out
Hang on.
sunset times, we use the equation of time, which uses the mean apparent sun. And in your paradigm, the sun is not actually where you see it at all. Certainly at sunset.
It
And
has,
it,
well, we see it 8 minutes later than the lights
and then in
moved
addition,
away
and then
from
an
the sun.
additional
Hang on. Look, could I finish? The sun hasn't moved that much in those 8 minutes. It moves 15 degrees per hour. So 8 minutes, what would that be? Less a degree or two? That's where we see it. It's just that it has moved a tiny bit away from it.
That isn't all that your paradigm claims is the difference between actual and apparent position. Although I'm glad that we now have gotten to the point where you're acknowledging that even in your paradigm, we don't see the actual position of the sun. And you're right,
It
because you
doesn't
think it's
matter.
93.
Everything we
It
see
doesn't
is
matter.
apparent position. Everything we see is we observe an apparent position. The distance, of course, over distance, it's larger, but everything is light coming to our eyes. So the object you are seeing has already, if it's moving, it has already moved. So we always see the apparent position. And 8 minutes, the globe model is what? 15, 8, about half a degree or so off where it actually is.
Okay, bro.
Okay, next. So what now?
So first of all, it's 8 miles a minute. You said it didn't move that much. I mean, it's thousands and thousands of miles. It's thousands and thousands of miles away from where it actually is, based on where we're
Not
seeing it
from
in your paradigm. Thousands of
not
miles,
from us, our
thousands of
perspective.
miles. Oh yeah, but out in space it's thousands of miles. Now, it's not just that though. That isn't the only thing, though. There's another additional 5-minute range that it fluctuates within in your paradigm based on the atmosphere. So if you were to just go out on in the world and say, take the globe model and do the geometry and say, okay, based on the geometry, based on the distance to the sun, based on the 8 light minutes, this is the time we're going to see the sunset, you would be wrong every single time.
It doesn't matter. It would change 2 degrees for the apparent sun and where the sun is only 2 degrees over 8 minutes. And then you add, as you said, a tiny bit from the atmosphere. That would not tell us on a flat Earth. Still, the sun had to be fucking 100,000, 140, 50,000 miles away from me before it could even get close to 2, 3 degrees above the
Assuming
horizon.
you see the actual position, and let me just address this guy
No,
here in the chat.
no,
Says
the
we
apparent
don't know
position.
where.
The
Says
apparent
we don't.
position.
Says we don't
The
know where the
apparent.
sun. Okay, can you chill, man? This guy in the chat says we.
What's it anywhere on the
What's it?
planet? No flat
What's it
Earth
says?
model will ever be able
What
to
in the
predict sunset
world is
and
going
sun.
on right now?
Hold on, John. Your mic was really garbled.
And like really right in the
I
middle
didn't.
of a sentence.
Sorry, I
And
didn't
his
mean to
voice.
be unmuted.
Oh wait,
Okay.
all right, you're better now.
Okay,
Wait.
so the real fast. This guy says, "What's it says? We don't know where the sun is, and says it's thousands of miles away in a few minutes." Yeah, I was addressing within their paradigm. Like if the sun's going 66,600 miles per hour, right? Then it's going like just over 1,000 miles per minute. So 8 minutes, it's going many thousands of miles away from where it supposedly actually is. Anyway, so it was from within the globe paradigm. The point that is very simple here, right? If we actually have a phenomenon on the Earth where the sun is relative to the observer, so it's just an apparent position specific to the observer, then to try to put some like mathematical distance and assumption of actual position to then tell me what the sun should be doing is ignorant. It's just erroneous and it's a futile pursuit and it's a strawman fallacy. And all this is a deflection away from the false claim that you can't have the sun disappear from the bottom up on a flat earth and that you can't have things disappear in the distance and not be visible unless it was behind the curve. Both of those things are provably wrong. Any glober that continues to say them is being intentionally dishonest. Also, it'd be very enlightening or refreshing, I guess, if a globe earther could still man my explanation for why the sun and the moon disappear from the bottom up when it sets in the distance. Instead of just telling us that it's wrong and then, like, can you still man it? I've never heard a coherent, like, response to it as to why it's wrong, you know?
Excuse me for interrupting there. I just want to make an announcement. I put 2 videos in that may help the Globers understand, distances, especially with the moon in this particular case. Okay, one is from Robert Pisano, beautiful, magnificent video, and the other one is from Eric Dubay, best high altitude video ever. Please have a look, and then maybe that might help you to understand what Witsit's trying to tell you. Bye for now. Thanks.
Thank you, Jen.
Like, I mean, have you guys ever heard of a globe earther still man the flat earth position on a sunset prior to claiming it
No.
doesn't work? Yeah.
They don't
Because
even
it seems
care.
like so simple. Yeah.
They don't even
Seems so
care
simple,
to.
right?
That should be required to get your license. It should be a requirement.
Well, it actually requires intention to avoid doing it, and like to do that for years seems wild to me. Or similar to like, oh no, we should see way further away if it was actually flat. That Canada video just destroys that.
Not
Or the
anywhere on
claim
the
that
planet.
the claim that only things can only be obstructed in the distance if it's Earth curvature, like that video just completely destroys it. So they intentionally ignore the video altogether and the implications of the video, or that the sun disappearing from the bottom up can only happen on a globe because the Earth curvature is physically blocking the bottom of the sun. But then I show that video and picture of the sunset disappearing, bottom up, horizontal cutoff, like we always see, up above the horizon. They just completely ignore it and the implications of it. And then they claim the sunset's impossible on a flat Earth, but they just intentionally ignore the actual explanation as to how the sun would set the way we see it on a flat Earth. It just seems weird to me. It's like, are you really sure it's a globe? Like, are you really sure a flat Earth? Because I'm so confident that the globe model's not true that I oftentimes still man the globe. Right. So maybe that's what it really is that you guys aren't actually as confident that flat Earth is wrong or that these things are actually impossible on a flat Earth as you portray.
So I strongly recommend, given what Austin just said, you stop appealing to this false idea that there cannot be or is not bottom-up disappearance along the horizontal surface. Stop appealing to that.
It's like, I guess, I mean, what am I missing here, right? So, like, in perspective makes things above us appear to ramp down and makes things below us appear to ramp up. And this is a well-known fact. Like, if you see a plane flying towards you in the distance, it'll look like it's actually moving at an angle up, and then it'll go over your head. And then as you turn around, it'll look like, as it's going away from you, it'll look like it's going down, like dipping
Right.
down at an angle, right? It's just a well-known phenomena. And even to explain what we see, the globe has to invoke this phenomenon, because like when you get in a plane and you fly up in the air, the horizon rises up with you. And then Globers always jump in and say, it's below eye level. That's just a complete deflection away from the point, which is that it rises with you. Or if you take a drone on a beach and you go up, the horizon rises with the drone. But on a globe, it's physically going down and away from you only in all directions. So as you go higher, you're going up, the ground's going down. It should only go further away from you, but it actually rises with you. So on a globe, you have to claim that perspective makes the horizon appear to rise with you. Like, you have to claim that. And it's just a well-known fact that perspective does that. Perspective makes things appear to ramp up if they're below you and appear to ramp down if they're above you. So when we say, okay, that's what's happening on a flat Earth, because that's what happens in reality every time we look at anything, which is like the skies above us, it's appearing to ramp down. The ground's below us, it's appearing to ramp up. And then they appear to converge. But it's just an optical effect. The sky doesn't ever actually merge with the ground, just an optical effect. They appear to merge into what we call the horizon, an apparent location, right? It's like a vanishing point, convergence point. The moon is up high above us and it's moving away from us. So, like everything else, it looks like it's going down and it's moving out into that vanishing point. As it starts to reach that vanishing point, the bottom of the moon is going to reach that vanishing point first, because it looks like it's going down. So if I draw a line out in the distance and I take the moon and I make it look like the plane does when it flies away from me, like it's dipping down at an angle, the nose of the plane in that analogy is going to look like it's hitting the horizon first, just like the bottom of the moon is going to look like it's hitting the horizon first, right? Because it's going down due to perspective. So it disappears into the vanishing point, bottom up, because it would have to, because it's above you, but appears to be going down due to perspective. That's the actual flat Earth position about sunsets and moonsets. So, like,
In
that's why
addition
it's
to
an
that,
inside joke with last thing. That's why it's an inside joke amongst flat earthers, that Glober still claims sunsets are impossible. It's because they can never even actually articulate what I just said.
And in addition to that, when you watch the plane take off and ascend and fly away on a clear day, even you watch the plane long enough, just go away, go away, go away, up and away on a clear day, get so far away, it's not visible anymore. That's not because a convex surface is obstructing it. Nothing between you and the plane except the air.
John, you're unmuted and hot mic again, bro.
Hey, I'm sorry. I don't know how that keeps happening. I come in, I'm unmuted, I am muted, and then it just unmutes. Anyway, I'm sorry. Hey, but if you'd like, we can talk about the Horizon Dip thing. It's easy to check it out. The Theodolite app, I think you know how to use that now. You can use a simple, there's like a $20 device that'll show you a degree. Go up in an airplane, find a clear horizon. The horizon dips about 3 or 4 degrees from commercial airliner heights, goes down progressively the higher you go.
Before you get into
That's just
that,
a
let me
fact.
respond to something. Before you get into that, let me respond to something Witsit said. They have to agree that perspective's causing the horizon to rise with them. I couldn't even get the guy to agree that the horizon's rising with them, let alone the reason why it's happening.
And what's funny is McToon at dinner, because I made the point the night before we went to Antarctica and Punta Arenas that the horizon from the water outside the restaurant was like way up in the sky with us in this restaurant that was kind of up on this hill. And I made that point and I started laughing and saying like almost every Glober like denies it and refuses to. And he said not one single globe earther has ever denied that. That's what he said. So he's running around pushing the narrative that every globe earther acknowledges that the horizon rises with you and it's just due to perspective.
Oh,
I'm like, no.
that would be news to me. Everybody knows, McToon certainly knows that the horizon dip in arc minutes is approximately the square root of the altitude of the eye in feet. If you go up to the top of the Empire State Building and look out, you'll see the horizon about approximately level with the tops of the Verrazano Narrows Bridge. And you can do some calculations and see that that's about a half a degree.
Dude, this is what says like it's just so funny that like you're just doing it live, because it happens every time. Like when you get in a plane, the horizon rises with you. That's just a fact.
No, it
Like if
doesn't.
we were seeing it, it absolutely does rise with you. You're conflating that. You're conflating that it's below eye level with it doesn't rise.
Well,
Not the
what then?
same thing.
Then what do you mean by rising with you if it drops below? You look out at a constant,
Oh,
you look out at eye level, you keep your eyes level all the time, the horizon drops further and further below eye level.
he doesn't get it. So like on a globe, if I'm standing on a globe, the earth is going curving down and away from my feet in all directions. If I would jump in the air, I'm going up and the ground is only going down. If I get in a plane and I start to go up, I'm going up, but the ground in your paradigm, the globe, is only going down and away from me. Period. Shouldn't rise with me at all. But it does. As you get
It
higher in a
doesn't.
plane, it
No,
literally does,
do
though.
you agree that it drops below eye level?
See,
Deflection.
he's ignoring that. He's
This is what
ignoring
they
what you just
all
said.
do, dude. This is
Do
what they
you
all
agree?
do.
Do you
He's
agree that
digging
it
in his heels
drops
to do it.
below eye level?
Diversion. Red herring
Do
fallacy.
you agree that it drops below eye level?
Do
I'm
you
not addressing
acknowledge
your
the
red
fact that
herring.
Austin just said?
Yeah. Acknowledge my facts before I address your red herring.
Well,
Do
I
you
don't know what you can
acknowledge the fact that Austin
possibly
just said?
mean. I don't know what you can possibly mean by going up with you if it drops below eye level. That means that your eye, to look at the horizon, you have to progressively look further and further down. That
It's
is
like he
not
genuinely
rising with
doesn't
you.
undernd what he did.
So
Yeah,
he said he doesn't know what you
understand. Can
mean,
I
but then he
explain?
continues to follow up with his digression.
Yeah. Sorry, can I explain 10 seconds? That's all it is. Basically, it's indicative it's indicative of a leveled surface. Okay, so what's happening is I'm in a helium balloon. I'm rising up now. I'm looking out to the horizon. Okay, so I can see the horizon, and it appears that it's rising with me. The reason for that is because more and more of the Earth is being exposed as I go up. See, at a curved surface, it would fall away from me. Yes, the Earth is below me. That's a fact. There's no doubt about that. I am above the Earth. But it's an optical illusion, is what we're saying. It appears to be rising up with us. That's the indicative of a flat, leveled surface. The higher you go, the more that's going to be revealed. And that beautiful
Nope.
sensation to witness. Yes, it is.
But you're
Yes,
kind of
thank you.
taking the
So
bait
so what
in a
so
way.
let me
He's gonna
just let
just
me go
take
through
this
this
as if he
again.
took the bait.
What you said was right. As you go up, you see more and more of the earth. That does make it appear that the horizon is rising. It does make it appear that the horizon is rising, but there is no objective way to justify the statement that it does rise, because when you look out at in a horizontal direction, the horizon only gets further and further below that direction.
Oh my gosh,
You
this
are
was
Doesn't
correct,
embarrassing.
entail the
exactly. Hang
surface
on a
is
second. Please allow me
convex,
to speak. Yeah. Okay, go ahead.
Okay, this
right?
is really simple, right? It's like in the globe paradigm, the Earth is physically curving down and away from you only, so it doesn't rise with you at all. It does rise with you, so then you always all deflect over to, it's not exactly at eye level, it's below you. And the higher above the earth you get, the higher above the earth you are. It's like, no way. As we get higher above the earth, we're higher above the earth. Yeah, that isn't exclusive to a globe, but that's a deflection, right? It's a red herring. And the simple point, and you said it does appear to rise with you, but there's no justification to say that it does. The horizon just an apparent location. So what it's appearing to do is what the horizon is. And
Nope.
even in your paradigm, the horizon is only an apparent location.
You can measure the location of the horizon relative to your eye level. You look out straight horizontal, measure the angle down to the horizon. That angle monotonically increases with altitude.
Monotonically.
That isn't exclusive to a globe, though, because on a flat Earth, you're getting higher above the ground. So the horizon is where the sky appears to meet the ground. So as you get higher above the ground, then where they appear to meet is going to be relative to your height above the ground and other conditions, by the way that the atmo is operating in between you and wherever you perceive the horizon. And this is all just a very simple point. And McToon scoffed at it and said that no glober ever denies it. And I informed him that 99.999% of them do, which is that even in a globe paradigm, you would have to say that because of perspective, the horizon appears to rise with us. Okay. And that those are not contradictory unless you're not understanding it. So it's like, let's put it in really simple terms. Say that based on the geometry of a sphere, if I go 10,000 feet, just random numbers, if I go 10,000 feet, the horizon, the physical geometric horizon should be 10 degrees below me on a sphere
At
because
what
it's
at what
only going.
altitude?
I
At what
just said the
altitude?
numbers don't matter, dude.
Okay, well, I just thought you were quoting numbers. So on a flat
You
Earth,
interrupted me because you didn't
oh, I'm
understand, and
sorry.
then once I
Okay, go
had to
ahead.
let you speak because you interrupted me, you're like, now it's my turn to speak. You have no conversational etiquette, man. So, dude, the numbers don't matter. They're making a point. Say we're on a globe and we go 10,000 feet up based on the geometry of that globe, the physical geometric horizon should drop 10 degrees below, just purely geometry, assuming that we see the actual physical location of the curve and that is the horizon. So we go up 10,000 feet, it should be 10 degrees below us geometrically. But we see it at 5 degrees below us. Okay? In the globe paradigm, we would have to say, well, geometrically, it's 10 degrees below us, but because of perspective, it makes it appear like it's 5 degrees because the ground appears to ramp up due to perspective. So it's somewhere in the middle ground of where it actually is because we have to account for perspective. That is the stillman of the globe. Like you have to actually invoke perspective to explain the perceived location of the horizon, even from within a globe paradigm.
Okay, so first of all, on a globe, on our globe, on the Earth, at 10,000 feet, the horizon drops about 1.5 degrees. That's just a fact. Now, on a flat Earth, the horizon does rise to eye level. That's a simple matter of the fact that if you are looking down at all from eye level, your line of sight runs into the ground. So any amount of looking down from eye level will run into the ground. Any amount of looking up from eye level will run into the sky. So the horizon is always at eye level on a flat Earth.
You see what he did?
Patently
He
false.
completely avoided the point. Like he just completely avoided it. And I even gave really simple terms and I pointed out that the numbers don't actually matter. It's just to make the point. What was his first response? That the numbers were wrong and that's just a fact. Yeah, I know the numbers are wrong. That's why I said we're just going to use really simple round numbers because the numbers don't matter. We're talking about the points. And then you just straw man and said that we should always see the horizon at eye level on a flat earth. That's incorrect. Okay. For one, the horizon is just an apparent location. The higher you go, the wider that like the span of that convergence point is in reality. That's why every time you go in a plane and you go look out at the horizon, you're going to see this huge gradient of colors. Like the
It's
quote
Nor
unquote
does a
It's
horizon.
terrestrial
irrelevant.
horizontal
It's not about
surface.
the fight. It's not about
He has to
field of
acknowledge this
view.
also. Nor does a terrestrial horizontal surface necessarily entail that it spans an infinite distance.
So I mean,
You
I
can't
just
see the
this is
full
a really
span of
simple
the
point.
earth regardless. It's like it just rises towards eye level. And then
It
based
does
on conditions
not
and stuff,
rise toward eye level. That's just
so
not
so
true.
you don't even comprehend the globe that is literally my point. Thank you for just continually elucidating my point that McToon himself made fun of, literally made fun of
Well, I'd
it.
like to hear
And
McToon. I know McToon is a
me
smart
too.
guy,
I
so
have
I'm
it on
pretty sure he
recorded.
didn't say
I have it
that.
recorded. I have it recorded.
I'd like to hear it.
Okay. And this is what's so funny, bro. It's like because he was there around other people that all understood basic concepts. So when I was pointing out, because they were trying to act like flat earthers were so stupid, and I was pointing out that my experience is actually that the vast majority of globe earthers don't understand basic concepts. And we started talking about that one, and he was super condescending and arrogant and dismissive and said, that's not true. Every glober, no glober has ever said, ever denied that you have to account for perspective as well. And that perspective exists on a globe and makes the horizon appear to slightly rise up towards eye level. Like, dude, McToon, I've almost never heard a glober understand it. He's like, no,
Here's
no, all of them do.
So here's what makes the horizon slightly rise up toward eye level is refraction. But as you rise, the horizon drops, refraction or no. The higher you go, the lower the horizon is. It does not rise toward eye level. It drops away from eye
And it
level.
does
And
not
it doesn't,
convex
and
the
it would
more you
not
increase your
do
height.
that
And it does
on a
not
flat earth.
convex. And it does not convex the more you increase your height. The objects along the surface of the earth never curve down and away as you increase your height. So the
That's just not
consequence
true.
of a convex surface of a spheroid is never occurring when you increase your height. So
And this
when
guy
you
just
appeal to drop over distance as you increase your height doesn't entail nor strongly indicate nor necessarily indicate that it's happening above a convex surface of a spheroid. That's Austin's point. I
he
can
just double
condescendingly
spoke.
speak in a rhythmic tone just like you.
He just double spoke anyway. He said that it does appear to rise, and he claimed it was only because of refraction. showing that he doesn't even understand his own model.
what I
but
meant
then
is to say,
but then claim that it doesn't ever do it at all, which was his original claim. He's made that claim 5
well,
times.
so here,
Here,
no,
John,
look,
let me ask
now
you a
you're
very simple
misquoting
question.
me. You're
Let me ask
misquoting
you.
me.
No, I'm
Now he
not.
has to be
Let me ask you.
interrupted.
Let
Yes,
me
you
ask you,
Now
are.
he has to be
John.
disrupted.
John, stop, man. Let me ask you a very simple question. Do you agree that perspective makes things below you appear to ramp up?
I agree that perspective does a lot of things, but you can measure things and overcome perspective.
Do you
There's a
agree that perspective makes things below you appear to ramp up?
Well, I don't know what you mean by up. You mean when you look at the ground at going away from you, it looks like it's going upward?
Yeah.
Is that what you mean? I don't think so. And I don't think I've ever
Uh,
experienced that feeling. But if so, it's
okay.
an illusion, right? I mean, you know, it's an
Oh my god.
illusion.
Wait, time out. Okay,
I mean,
now, okay,
no, I mean,
let's use it
when
the
I
other way
look
around.
down,
Wait, time out.
when I'm in a
Calm down, man.
plane,
Calm down.
when I'm in a plane flying along, I see the land stretching out. I see it stretching out toward the horizon. I see that the horizon is about 200 miles away. Typically, I've flown along the Sierras. You see the San Francisco Bay Area. That's about it. Um, I don't have the visual. I don't have the impression that the land is sloping upward. But
Okay,
I mean, I
okay,
understand
calm
what
down.
you mean. Perspective. You know,
Well, you're
it's
starting to freak
rising
out because
in
you can
your
tell
field
that
of vision.
if I get to continue down the line of questioning I've now introduced without you interrupting, that you're going to be forced to concede. And that's why you're becoming frantic. But it's all good. So, perspective causes things below you to ramp up and things above you to appear to ramp down. And I asked you if that was the case, and you said perspective does lots of things, and then still refused to answer, and then claim that you've never seen or experienced that. So, have you ever seen a plane fly away from you in the distance? So say there's a
Okay,
plane
so
in the sky. Wait, I need to
so
know
I
the answer to this
understand.
question.
Yeah, I know.
Uh,
Go
Okay, the
ahead.
plane appears to be flying at an angle up as it comes towards you, then it goes over your head, and as it flies away from you, it appears to be going at an angle down.
Right. See, I wouldn't describe it that way, but I know what you're saying now. The point is that in your field of view, more distant things on the surface are higher in your field of view. Yes.
Oh, okay, so perspective causes things above you to appear to ramp down and things
Right.
below you to appear to ramp up. Okay, so if I'm on a globe, that doesn't mystically dissipate. That doesn't suddenly stop becoming reality. That's just an observed part of reality. So if I'm in a plane and I'm going up, it doesn't stop happening. Perspective causes the ground to appear to ramp up and the sky or what's in the sky to appear to ramp down. So to still man the globe, you would claim that the earth is physically and geometrically curving down and away from you only, but that perspective creates this illusion where what's below you appears to ramp up. And so that's why when we actually measure the amount of degrees below eye level, it's somewhere in the middle of the geometric prediction of a globe. And that is the still man of the globe model. And 99% of people that argue online for the globe don't understand it.
No, I get that land further away that you can see ramps up in your field of view, right? But it does not get to eye level before you start seeing sky. And then the ground beyond that becomes invisible because it's on the other side of the horizon. You can only see about 200 miles from a commercial airliner because of the curvature of the earth.
So when I first introduced this point,
But
I
let me
made the
just
point.
finish one thing more. Just be clear about this. And in a commercial airliner, the horizon is 3 or 4 degrees below eye level. On a flat Earth, it would be at eye level.
Okay. So when I first introduced this point, I predicted exactly what John would do without knowing John was going to be in the conversation, right? I introduced the point to make the point that he then elucidated, literally, which was every time that you point this out to a globe earther, which is that perspective causes things above you to ramp down, things below you to ramp up, because this was in the context of their inability seemingly to still man a sunset on a flat earth, right? They start denying it, and then you have to point out to them that this is the case even from within your paradigm. It's just how perspective works. Look at clouds in the distance, look at a plane fly away from the distance, whatever. We just know that this is the fact, right? And that the horizon should technically never appear to rise with us at all. Meaning that as I go in a plane, it should never come up with me at all. It doesn't matter if as it comes up with
doesn't.
me, it does. It doesn't matter that as it comes up with me, the distance between my eye level and it slowly increases. Overall, it's still rising up. Meaning,
That makes
obviously, the distance
no sense. That makes
that
no
shows,
sense.
and it just means you fundamentally are inept in terms of spatial reasoning. And I don't want to be that blunt about it, but you're just like being very condescending while being so blatantly wrong. So those are not mutually exclusive, they're different things. The distance between the rate at which the distance between your eye level and the horizon increases, right, can either be faster or slower. Since perspective is causing it to appear to ramp up, it's slower than would be geometrically predicted by the globe Earth. That is just a fact. It is just a fact. Anyone that truly understands the globe, such as McToon, right, readily acknowledges this and in fact tries to run cover for his globe Earth community by claiming that every glober understands this. And they don't. And this is actually why they also don't understand our argument about sunset, which is what the actual conversation was. And when I brought this point out, I said, what always happens is whenever you start to break it down for them, they just immediately deflect to, oh, it's not at eye level, thinking that's some type of rebuttal, but it's not. And that's literally what you're doing. You're doing the very thing that I predicted in my initial explanation. And again, just to wrap this all up, because I'm not doing this all night, it's like the actual point, though, was that this is tied to their inability to still man a sunset, which is that the sun is above us. So would the moon be. And so as it moves away from us, since it's higher in the sky, it appears like it's going down, just like the plane, just like the clouds, just like the hot air balloon, just like everything in existence, just like the kite. Doesn't matter what it is. So it appears like it's going down. And since the sky does that and the ground ramps up because of perspective and they appear to converge, because that's what the horizon is, where the sky appears to meet the ground. It's just optical. They don't actually morph into each other. It's just an optical effect. It creates a vanishing point where they appear to intersect. As the moon goes down, as the sun goes down, optically, due to perspective, as it moves away, it goes into that vanishing point. And of course, the bottom of the moon or sun would be the portion of the sun or moon that would go into that vanishing point first because it's appearing to go down from a position higher than you, which means the bottom would hit the vanishing point first. That is a stillman of a sunset or moonset on a flat earth, and almost no glober understands this. It seems that the basic observation of perspective eludes them entirely.
Okay, so you've changed the subject to sunset, but I'm game. A sun that moves toward the
I didn't
horizon at a
change the subject to
constant
sunset, dude.
altitude, when a sun that moves toward the horizon at a constant altitude, let's say 3,000 miles, will be will be some size when it's overhead. It'll be half that size when you see it at 30-degree elevation, because when it's at 30-degree elevation, it's now twice as far away from you as it was when it was overhead. That's just a simple trigonometric result. It'll be a quarter that size when it gets to be 20 degrees or something like that above the horizon. If you send that sun or moon 18,000 miles away horizontally, and I think we would all agree that that's something like the furthest it could ever get away from you on a flat Earth. So it's 18,000 miles away,
When did we
3,000
ever
miles,
concede to that?
3,000, hold on, 3,000 miles high. That puts it 10 degrees above the horizon, and 1/60th of it, not 1/60th, I'm sorry, a sixth of its size. It's 18,000 miles away, 10 degrees above the horizon, 1/6 of the size that it was when it was overhead. The moon does not do that.
When did
It's
we ever
all red
concede
herring
the sun to
fallacy.
be at any particular distance?
Well, don't take the bait. It's just a red herring fallacy. Like we're talking about the fact that the sun appears to go down and disappear from the bottom up, and they claim
It
that that's
doesn't ever
impossible on
get
a
to
flat
the
Earth.
horizon.
And people claim that that's impossible on a flat Earth, and I just
The sun
explain that it's
can't.
not. I just
Sun
explained that
can't.
it's not.
The sun
Stop interrupting
cannot
me, dude. Stop
reach the
interrupting me,
horizon.
dude. Stop. Okay, this is why I'm gonna just disengage, because for one, you always interrupt me because you know you can't actually rebut my true arguments. Also, you just blatantly and overtly use red herring fallacies. So I would just be here for the next 7 hours until you tap out, because we'll never actually get to the conclusion of a point because you'll always just deflect away from it with no shame whatsoever. That's what you've done both times. First example, I point out that in the globe paradigm, the Earth can only go down and away from you, but it does appear to rise with us. So you would have to claim that
Nope.
perspective also plays a role. And then you just started conflating two different things and deflecting with the red herring fallacy to the fact that it's below eye level. Then I started talking about the original point, which was what you either were or were not present for. And you claimed I changed the subject, but it was the actual original point that you disrupted, which was that Globers can never even seem to still man a sunset on a flat Earth. But it's a very simple concept as to how that happens. Understanding perspective as well, which is that it will appear to ramp down, and the bottom of that object, the sun and or moon, will appear to go into the vanishing point first, right? And then you deflected away from that to talk about angular size, right? You didn't address that at all. There are tons of Globers that claim the fact that the sun disappears from the bottom up into the horizon, like the sunset itself is impossible on a flat Earth, but none of them can still man it. When I then go and explain it, you just immediately deflect with the red herring into angular size, which, side note, has been, I have addressed that with you specifically multiple times and told you that I told you to provide an actual piece of evidence with a solar filter where the sun doesn't change angular size at all, because everything that's been presented claiming that we count the pixels and it does change, you just completely avoid that every single time and pretend that the conversation didn't happen, then just pop up in another conversation like this just to say your same script again. And lastly, you guys all do the same thing. You just, like Gregory was pointing out, you just straw man us, come up with some arbitrarily determined distance to a physical actual location, and start spewing off a bunch of numbers like it's some slam dunk when you're arguing against no flat earther that exists. And is none of that is our actual position. So this is just extremely disingenuous from top to bottom. It's all tactics. It's very lame to me. So I'm going to disengage unless you can still man the sunset on a flat earth, not anything to do with angular size. I'm not talking about
Okay,
angular size.
let me try and let me give a little help from you. How far, what is the furthest away horizontally that the sun can ever get in your model?
Okay, I'm
You gotta be
disengaging.
kidding me.
I'm disengaging.
Oh, he's
You gotta
gone.
be kidding
Yeah, I
me.
kind of figured. When it comes to numbers, Witsit always runs.
So
And
just
that's, in other words,
defiantly
just
repeat
be
a
clear
question
about,
that
just
tacitly
be clear
presumes
about
the
the,
very error that he just refuted, and then chant yourself the victor.
well, he ran,
Yeah.
didn't he?
No, I'm just like, I have more intellectual respect for myself.
So
Like the
what's the
conversation,
furthest
I want to
distance?
participate in a
What
conversation
is
that's
the
significantly
furthest?
higher level than what
Yeah,
you have
right.
the capacity to provide.
You
No.
just want to, yeah, you just want a gish gallop. What is the furthest distance that the sun can ever get from us in your
Red
So just
herring.
model?
insistently
Red
repeat
herring.
a question that is committing the very error that he already refuted.
So
Yeah, I'm
you're
just gonna
not
actually
going to
disengage.
answer.
No, the tactic
Can
of the
it
ha ha
can
he,
it get
the tactic of
30,000
the
miles? Can
tactic
it
of
get
the dude. I
30,000
don't want to
miles
have to.
away?
I really don't want to have to
You
have
really
my own
don't want to get into
conversation.
numbers.
But okay. See, so like the
Wow.
tactic of the ha ha, he had to run away. He can't do math. Like I shouldn't have taken the bait. I really tried not to. I took the second bait. It's just a desperate tactic to try to rein me back in. But I'm gonna pass. I talked very long, but I was really just trying to fully explain the concept for anyone that's listening. And to all flat earthers, I think that this is very important. It's just like tell them I'm not moving forward unless you can actually still man my position, because this is coming across very disingenuous. Like
Right.
you don't respect me at all. You don't respect my position at all. You don't intellectually respect anything I'm saying. You're not even listening to it. You just have a script that you want to say, and you want to straw man me within that script, and I'm just not participating. Because if we don't like kind of adopt that approach across the board, then we're just going to keep spinning our wheels forever. because they're going to always come in with their script and they're going to always get you to deflect. And then it's sometimes very difficult not to take the bait, right? Like, for example, to be like, wait, when did any of us say those numbers? Got us, right?
Put the
Because he was
foot
deflecting.
down. No toleration.
Yeah, you
Put
literally
the
have
foot
to. So,
down. No toleration.
everyone can do whatever they want to. I'm just saying I'm doing that right now. I'm also, because I'm just also busy, and like I can't just go in circles with red herrings. I think it's like gross. Makes me feel gross. Like I need to take a shower.